We're going to take a look at Exam 4 test review. So in this test review, it's got everything from the entire semester on it. So let's start with this first question. This question would most likely show up as a written section, so part 2, and it will have one problem where you have to solve that problem using complete the square, and then you have to solve that problem using the quadratic formula. So let's take a look. Let's start with complete the square. I think complete the square is a little bit quicker, but you can always run into a couple problems with fractions and things like that. Whereas the quadratic formula, it's the same process throughout. This is coming from section 32, or 31 and 32. So complete the square will be from section 31. Quadratic formula will be from section 32. All right, so when we complete the square, I'm going to zoom in here. We want to first move that C term over to the right side. So we'll subtract that over. And then we want to make sure that the value in front of our x squared is a 1. So since it's a 3, we need to go through and divide every single term by 3. That gives us, a x squared first, and then 18 divided by 3 is 6x, and negative 12 divided by 3 is negative 4. So then from there, we are going to do the complete the square process. So when we complete the square, we take this b term, so the negative 6, and we divide that by 2. We get negative 3, and then we take the negative 3 and square it, that is 9. So we're going to add 9 to both sides of the equation. What that does is it gives us a perfect square trinomial, so that now this left side we can factor into a perfect square. Okay, now we know that once we have a perfect square, we can use the even root property to solve for that perfect square. So to undo a perfect square, we square root both sides. Don't forget the plus or minus of the right side. So we've got x minus 3 equals plus or minus the square root of 5. And then the last thing we need to do is just get the x all by itself. And we end up with 3 plus or minus the square root of 5. And that would be our solution. The cool thing is about this problem is that whatever method you are the best at, you can do that one first to get the right answer, and then you can do the other problem to kind of work your way to the answer. All right, so that's the complete the square process. This one is pretty quick because we don't end up with any fractions or anything. But let's take a look how we can solve the quadratic formula using the using that we know the answer is 3 plus or minus the square root of 5. All right, so the quadratic formula, let's just do a quick reminder of what that looks like. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, and we know our a is 3, the b is negative 18, and the c is positive 12. So let's plug those pieces into our quadratic equation. So we have negative b, our b is negative 18, plus or minus b squared, so negative 18 squared, minus 4 times our a times our c, all of that over 2 times our a. Okay, So once we have that, we're going to start cleaning up the problem. We've got x equals negative 18. If you know to change the sign on that right when you put it in, that's fine. I am going step by step here. So then we need to do the square root of, and then let's see, negative 18 squared. Which, let's see, 18 squared is 324 minus 4 times 3 is 12 times 12 is 144. All of that over 6. Okay, a little bit more cleanup inside my square root. We have 324 minus 144. That gives us 180 over 6. Okay, so then we need to simplify this. I'm going to take that 6. Actually, I'm going to simplify my square root first. So 180, my guess is it has 36 as a perfect square. And the only reason I'm guessing that is because I don't have any fractions in my final answer of complete the square. So I'm going to go 180 divided by 6, or 36, and see if there is a perfect square there. And that's going to be 36 times 5, which ends up being 18 plus or minus 6 square root of 5. And I'm going to take that 6 and divide each of my terms. And that gives me 3 plus or minus the square root of 5. Those have to be the same answer because they're the same equation. You're just solving it 2 different ways. All right, so that problem is solving the quadratic equation. There's other ways we've learned to solve quadratic equation. We learn to factor, but this one won't factor because it's not a perfect, they're not rational numbers, okay? We also did the even root property, which we actually did a little bit of when we completed the square. Okay, let's move on to the second question on the test review. It says graph the quadratic function. We need to identify the vertex, the intercepts, and the equation of symmetry. This problem has a lot to it. So we're going to start by finding the vertex. When we find the vertex, we're going to split that up into the x-intercepts, the x value, and then we find the y value. So to find the x value of the vertex, this is something you'll need to memorize because just finding the vertex will be a multiple choice question. But using the vertex to graph is going to be a written question, so it's going to show up twice. And this is from section 33. So if you want a review of that, that's where you need to go to find it. So the x value of the vertex, we're going to take this negative b, so negative 2 over 2 times our 1. That gives us negative 1. So that's the x value of our vertex. And then to find the y value of the vertex, you take the x value that you found and you're going to plug it into the equation. Because to find a point on a graph and you have the x value, to find the y value, you just plug into the equation. So we've got 1 minus 2 minus 3 gives us negative 4. So our vertex is negative 1, negative 4. And because my x squared is positive, this is going to open up. So let's plot that on our graph. So we have the point negative 1, negative 4. So there is our vertex. The next thing that we do when we're graphing is we're going to find the x-intercepts. And to find the x-intercept, we just take our equation, which is x squared plus 2x minus 3, and we set it equal to 0. We're plugging 0 in for y. So we can factor that. Okay, and we get here x equals -3 and 1. So those are our x-intercepts. If you want to write them as points, that they are the points -3, 0, and 1, 0, because we plug 0 in for y, and those are the x values. So if we plot those on our graph, here we've got -3 and 1. Okay, the last thing we want to do is we want to find the y-intercept. To find the y-intercept, we are going to take our function and we're going to put 0 in for our x. So we've got y equals -3. If you want to write that as the point, the x was 0 and the y is -3. So there we go. Now that we have all our information, we know it opens up, we found the vertex and all the intercepts, we can graph it. So I'm going to start from my vertex and I'm going right because there's most information right. And then the left side would just be symmetric here. And there is our quadratic equation graphed, quadratic function graph, sorry. Okay, so there's two things here that are going to be on the test. First, being able to graph everything, that's very important. That will be on the written section. Finding the vertex is going to be on the multiple choice. So make sure you can do both of that. You will need to know how to at least find the x value of the vertex without any equations or anything. But then when you go to do the written, you can have the process written down. Okay, let's take a look at the next page. We've got solve the inequalities, and we're going to write the solution in interval notation. So this comes from section 35. Okay, so what we want to do is we're going to put all of this good stuff on a number line. But before we do that, let's find the values that go on the number line. So I'm going to find the critical values or the boundary points of the denominator. So the critical value of our denominator is when is x minus 1, actually when is it not equal to 0 because it can't be 0. So we have x when x is not equal to 1. So if we put that on our number line, here's 1. We cannot be equal to 1, so this is always open. The critical value from our denominator is always open. Okay, I call it a critical value because it's the critical place where things change. It's either going to change from being positive to negative, or possibly change. Then we're going to find the critical value of the numerator. And that is going to happen, we probably should have factored, but we can take this x squared minus 49. We can factor it now. So we can go x minus 7, x plus 7. So our critical value of our numerator is that, or occurs at x equals 7 or -7. And those are going to be closed circles because of the greater than or equal to. It's the equal to that tells us we're closed. So we have here -7 and 7. Okay. I put them on the number line as open circles because we don't know which direction it's going to go yet, so I'm not going to use parentheses or brackets like some people do. I like the open circles and closed circles. Sorry, I didn't finish coloring those in. So there we go. We've got our closed circles on the -7 and 7 and an open circle on 1. Okay, now what I'm going to do is I'm going to test values formed by my critical values. Okay, so I have to pick something to the left of -7, something between -7 and 1, something in between 1 and 7, and something to the right of 7. Those are called test statistics or test values. Okay, we're going to plug those into our original equation. So let's start with the -10. -10 squared is 100. 100 minus 49 is positive. -10 minus 1 is negative. So this region is a negative region. Then I'm going to pick 0. 0 squared. Let's do this. So here we go. We got the 0. We're going to go 0 squared minus 49 is negative. And then 0 minus 1 is also negative. So a negative divided by a negative is a positive. Okay, then let's pick this -5 or +5. 5 squared is 25. 25 minus 49 is negative. I don't care what it is, I just know that it's negative. And then I'm going to take the 5 and go 5 minus 1. That is positive. So that's a negative over a positive is positive. And then the 10 last, we've got 10 squared minus 49. So 100 minus 49 is definitely positive. And 10 minus 1 is also positive. So there we go. Now we're looking for the regions that are greater than or equal to 0. Greater than or equal to 0 mean positive y values, the positive x values or the positive function values, or positive inequality values, however you want to say it. So the positive regions are the regions that are going to have positive y values. So those are the regions that work. So when we write the interval notation of this graph, we're going to go from -7 to 1. And then again from 7 to infinity. -7 and 7 have brackets on them because we can be equal to them. 1 and infinity have parentheses, and that is because we can't be equal to those values. So there's our interval notation. Okay, I'm going to do 4a, and I'll let you try 4b on your own. And I'll have 4b's answer on the written part, but I just want to give you one of these. It says, solve the absolute value inequality, graph, and write the interval notation. So this is going to be a multiple choice question, and you just need to recognize the graph. But we'll do the whole thing just to get used to an interval notation. Okay, so an absolute value inequality has two things happening. We either have 2x minus 5 is greater than 7, or 2x minus 5 is less than -7. We flip the sign of the second part right here because we multiplied that back part by a -1. I'm going to solve each one of these. 2x is greater than 12, so x is greater than 6. And then we also have 2x is less than -2, so x is less than -1. Okay, if we look at the graph that gives us, we have that x is greater than 6, so we cannot be equal to 6. So we're going to go greater than 6 and less than -1. So there we go. That is our graph. If we're going to write the interval notation for this, that would be from negative infinity to negative 1 with a parenthesis, and then from 6 to infinity. There we go. I forgot to mention that this is from, I believe it's section 4. Section 4. Okay. Not a very difficult problem, definitely multiple choice worthy. For question 5, also a multiple choice question, and I believe question 5 is going to be from section 7 and maybe a little bit of section 8. Yep, let's see, section 7. Let's go section 8. And also section 9, because we're writing the entire equation of the line. This is a multiple choice question where we need to find the slope. So the first part of this question is find the slope. They don't tell us to find the slope in the problem, but yours will tell you to find the slope if that's all you need to do. So to find the slope, we're going to use our slope formula. This is a multiple choice question, so you'll have to have the slope formula memorized, but going into college algebra, you'll have to have that formula memorized also. So it's important to have this down. So if we go and we find the slope, we're going to go y2 minus y1 over x2 minus negative 9, so minus x1. So that gives us a slope of negative 1 over negative 3, which is a slope of 1/3. So there's our slope. Now, the second thing we do when we're writing the equation of a line is that we need to find the formula in point slope form. So I'm going to go I'm going to pick the point negative 915 because the numbers are a little smaller. So y minus y1 equals my slope times x minus x1. Okay. Then the third thing I want to do when I'm writing the equation of the line is I'm going to solve for y. So I'm going to distribute the 1/3 through. That's 1/3 x. 1/3 times 9 is 3. And then let's add that 15 over. 3 plus 15 is 18. And there is the equation of our line in point slope or slope-intercept form. Question 6, this is also from section 9, is very similar to question 5. So it says, write the equation of the line that passes through the point 12, negative 5, and is perpendicular to the line 6x minus y equals 3. So the first thing we need to do is we need to find the slope. We know we have a perpendicular line whose equation is 6x minus y equals 3. So if we were to solve for y here, we get a slope that is perpendicular equal to 6. So if the slope perpendicular is 6, our slope here is going to be the negative reciprocal of that. So our slope is negative 1/6. So finding the slope is the very first thing. The next thing we do is we're going to put into our equation y minus y1 equals m times x minus x1. So what we're going to do is we're going to plug the pieces in. We know, so we've got y minus the y point, so minus a negative is a plus. Then we have our slope, which is negative 1/6 x minus the x point. Okay, and then step 3 is we just need to solve for y. So I'm going to distribute the negative 1/6 through. Negative 1/6 times negative 12 is like 12 over 6, which is 2. And then we just subtract the 5 over. We get y equals negative 1/6 x minus 3. And that is the equation of the line perpendicular to the line that they give us that passes through the point 12, negative 5. All right, let's move on to page 3. On question 7, it says solve the system of equations. So what we're going to do, you can do this whatever way you prefer, but I think that the easiest thing to do is solve using the substitute or the elimination method. So I'm going to multiply that top equation. I'm going to multiply it by negative 3 because then my 2x and my 6x will cancel out. So we end up with negative 6x minus 9y equals negative 15, and positive 6x minus 7y equals 31. Okay, and if we now add those two equations together, our x's cancel, and we have negative 16y equals 16. To solve for y, we're just going to divide both sides by negative 16, and we get y equals negative 1. So we know our y. Y equals negative 1. But we do have to find the x that goes with our y. So let's use any equation. I'm just going to use that 2x plus 3 equals 5. And I'm going to plug that negative 1 in for y. So we have 2x plus 3 times negative 1 equals 5. So 2x minus 3 equals 5. 2x equals 8. So x equals 4. Just solving your very basic linear equation. Okay, we have our x and our y. So our solution is x equals 4, y equals negative 1, or you can write it as a point, x is 4, y is negative 1. So that's solving a system of equations. I forgot to tell you that this is from section, section 11. As well as 8. 8 is also going to be from section 11. Okay. 8 is an application problem. It's not a terribly difficult application problem because the question is going to set you up. It's going to kind of tell you how to get the problem going. So it says, at a bakery, the total price for 3 cookies and 5 cupcakes is $31. The cost for 10 cookies and 3 cupcakes is $35. The first thing they want us to do is identify the variables and then set up a system of equations for the situation. So let's think about the variables. We have cookies. We don't know the number of cookies. And we have cupcakes. We don't know that either. So those are going to be our variables. Let's just let cookies equal x and cupcakes equal y. So the total price for 3 cookies and 5 cupcakes is $31. So if I have 3 cookies and 5 cupcakes, we paid $31. The next one says we have 10 cookies and 3 cupcakes. So that's 10 cookies plus 3 cupcakes is $35. So this is a system of equations that relates the two variables together. When you have two variables and two equations, you can always solve for those variables. Unless for some reason you get like no solution or infinite solutions. Even that is technically a solution though. So you can always solve a system of equations when you have two variables and two unknowns. If you have three variables, you could also solve as long as you had three equations. Okay, so the next thing that we're going to do, we're going to use the system of equations to solve for the variables. So we've got 10x plus 3y equals 35. Now we want to get rid of one of the variables. It's really your choice what one you want to do. I'm going to get rid of the y's just because we got rid of the x's on the last problem. So to get rid of the y's, I need to multiply the top equation by -3 and the bottom equation by 5. So we end up with the equation -9x minus 15y equals -93. And if we take the 5, we've got 50x plus 15y equals 35 times 5 is 175. All right, so from there, we're going to add the two equations together. -9 plus 50 is 41x. The y's go away, and that equals 82. So then we need to solve for x. We're just going to divide both sides by 41, and we get x equals 2. Now we just need to figure out what the y value is. So let's use this 3x plus 5y equals 31. We know x is 2 plus 5y equals 31. So that's 6. We're going to subtract 6 from both sides. We get 5y equals 25. So y equals 5. Okay, so we have our x and our y. Now we just need to answer the question. We know that we have, it's $2 per cookie, because my x represented a cookie and my y represented the cupcake. So it's $5 per cupcake. And we've answered the question. So we're good. All right, let's look at question 9. Everybody's favorite subject in the semester is factoring. So we're going to look at these 3 factoring problems. 9 is probably from section 11, 12, 13, 14, or 15. I'm going to say section 15 probably. So when we're factoring by grouping, we want to group the 2 pieces together, or group 2 to 2. So we've got to factor out the common factor there, and factor the common factor out in my second group. Okay, now they both have a common factor of x minus 10. So I'm going to factor 1x minus 10 out from each one, and we are left with x squared minus 4. Okay, so from here, we can factor that x squared minus 4 further. That is from section 18, I believe. Maybe section 17 also. We have x minus 10. We can factor that as a difference of the squares, so we have x minus 2. Or plus 2x minus 2. And there we go. Those are our 3 factors. Okay, section B, or problem B. This is from section 16. The very, very first thing that you want to do when you go to factor a trinomial is you want to factor out the greatest common factor. So in this case, every term has a common factor of 3. So I'm going to factor the 3 out here. I get 4x squared plus 16x minus 9. Okay, I'm going to factor this by taking that 4, multiplying the 9. We have x squared plus 16x minus 36. Okay, so we're going to look for the factors that multiply to get to negative 36 and add to positive 16. I believe that would be 18 and negative 2. 18 and negative 2. So we've got x plus 18, x minus 2. Now we are not done with our factoring here. We need to balance our problem back out. So we're going to divide by 4 here. We're going to divide by 4. We will reduce first. So let's see. X plus 9/2 and x minus 1/2. And let's bring our denominators up. So we've got 2x plus 9, 2x minus 1. And that's our factoring. We have to bring our denominators up because we are not solving. We are factoring, so we need to write the actual factor. So there we go. That is factoring B. I would say B is the hardest of the factoring. So that's the good news. C is not so bad because there's only 2 terms. And when there's 2 terms, you're going to use the difference of the squares. I think that the first thing we want to do is look for a common factor. There is a common factor, so there's a common factor of 4. So I have 4x squared minus 25. And then we have a squared minus b squared here. So our a is going to be 2x, and our b is going to be 5. I don't know why I wrote a 2. Let's see, 5. And then when we go to factor that, we have 4 times 2x plus 5, 2x minus 5. And there we go. The 4 just carries through the problem, stays out in front. So there's our factoring. We will for sure have a difference of the squares. There will be a factoring when there's not, when the x squared term coefficient is not a 1. And there will be a factoring by grouping. The rules for C come in section 17, I believe. So the whole factoring section was section 15 through 19. So just use those. They even have the section in section 19 with the roadmap. You might want to write that down on your note sheet to kind of help you. Okay, question 10. We're going to solve the rational equation, but first we have to state the restrictions. So to start this problem out, the very, very first thing we're going to want to do is factor the denominator. So we've got our denominator factored. We will then find the restrictions. So our restrictions will be where 2x minus or plus 1 can't be 0 and x minus 5 cannot be 0. So if we subtract 1 and divide by 2, we have that x cannot equal negative 1/2 or 5. So those are our restrictions. Okay, so from here, we're going to multiply our entire equation by the LCD, which is 2x plus 1x minus 5. So we're going to multiply this by 2x 1x minus 5, this by 2x minus 1x minus 5, and this one by 2x plus 1x minus 5. Okay, and what that does is it gets rid of our denominators. So our denominators should cancel all the way out. So we are left with 30 minus 6 times x minus 5 equals 15 times 2x plus 1. And then now we just have a nice linear equation to solve for. The biggest mistake here is not distributing that negative through, so I'm going to make sure I distribute -6 through the entire problem. And the entire parentheses. And I need to distribute the 15 through the entire parentheses. See, 30 plus 30 is 60 minus 6x equals 30x plus 15. I'm going to subtract the 15 over, that gives me 45, and add the 6 over. And then we just divide both sides by 36. And we need to reduce 45 over 36. I believe 9 goes into both of those. So we get x equals 5/4. And 5/4 is not a restriction, so that is our answer. Okay, so let's look at 11. Simplify the exponential expressions. So the first thing we want to do is we want to simplify inside the parentheses if we can. In this case, we can't. So then the second thing I'm going to do is I'm going to deal with this negative outside. So I'm going to rewrite that 1 over xy cubed to the second power. And then I'm going to distribute that 2 through. So 1 squared is 1, x squared, y to the third squared is y to the sixth. I'm also going to distribute this 4 exponent on my second parenthesis. So that would be x to the 20th, y to the 28th. Okay, so we have x to the 20th, y to the 28th times 1 over x squared, y to the 6th. And I'm going to reduce. So we've got x to the 18th, y to the 22nd. And every single variable is only listed once. We have an exponent with no parentheses, no negatives, so we are good. That is reduced. On B, a very similar idea. We want to reduce inside the parentheses first. So I'm going to reduce 9/27 reduces to 1/3. I'm going to bring that x to the 5th down, and it's x to the 8th, x to the 5th is x to the 13th. And let's bring that -3 up, that becomes y to the 12th. And that is all to the 4th power. So then we will distribute that through. So y to the 12th to the 4th power, we're going to go 12 times 4 is 48. 3 to the 4th power is 81. And x to the 13th to the 4th power is x to the 52. And there we go. We have that all the way reduced. All right, question 12. We want to solve for the radical. So here I'm going to isolate it first. Sorry, we're solving for x with the radical, but we want to isolate the radical. So there we go. And then we're going to square both sides of this equation. So if I square the left side, my square root cancels. And then the right side becomes x squared minus 6x plus 9. On the test 3, the mistake was made a lot where we didn't FOIL that x minus 3. You just put x squared plus 9. So you got to be careful. Make sure you FOIL that entire right side. Then I'm going to bring everything over to the right side. And so we have 0 equals x squared minus 8x plus 12. We will factor that. We're going to say, okay, that's x minus 6, x minus 2. So we have x is 6 and x is 2. Now, an important step for these is checking our answer. So we're going to plug back into the original equation. 2 times 6 minus 3 plus 3, does that equal 6? So let's see, 12 minus 3 is 9, the square root of 9 is 3, and 3 plus 3 is 6. So this one works out. Let's try the 2. 2 times 2 minus 3 plus 3. So 4 plus or minus 3 is 1. Square root of 1 is 1. Is 1 plus 3 equal to 2? It is not. So the 2 does not work. So our only answer here is that x equals 6. So there we go. Okay, let's look at 13. This is a nice long one. That's okay. We're going to divide 2x minus 4 into, let's see, 4x to the 4th minus 6x cubed plus 10x squared. No skipped variables. That's kind of nice. Okay, so we're going to divide the 2x into the 4x to the 4th. Okay, so that would give us 2x cubed. So that's 4x to the 4th minus 8x cubed. Change each thing's sign. We've got 2x cubed plus 10x squared plus 12x minus 16. So we're just going to keep repeating this process until we don't have anything else left. So we've got 2x goes into 2x cubed, x squared times. So that gives us 2x squared, and x squared times negative 4 is negative 4x squared. Okay, we're going to change each thing's sign. That gives us 14x squared plus 12x minus 16. We will divide the 2x into the 14. That gives us plus 7x. So that's 14x squared minus 28x. We will change each thing's sign. Okay. And we've got 12 plus 28 is 42x. Minus 16. 2x goes into 42 21 times. Oh boy. Okay, 21 times 2x is 42x. And 21 times 4 is 84. We will negative 84. So we're going to change each thing's sign. We end up with here 0. And 16 minus 84 would be 68. So that is our remainder. So our final answer would be, let's write this out, 2x cubed plus x squared plus 7x plus 21 with the remainder of 68. So we're going to write that 68 over 2x minus 4. Oh, that back part will reduce. We're not going to worry about that, though. So we are okay with this. This is our final answer. All right, 2 application problems on this test. Here's our second one. This one will be from section 34. I believe, yeah. So it says, a quarterback throws a football from an initial height of 4 feet. So here we go. We've got this. He's throwing it from an initial height of 4 feet. And then the height of the ball represents the equation. h of t equals negative 16t squared plus 80t plus 4. So the first question says, what is the height of the ball 2 seconds after being thrown? So that's our x. Our height of the ball is our h of t. That's what we're trying to find. So we're just going to go h of 2 is equal to negative 16 times 2 squared plus 80 times 2 plus 4. And this is going to definitely be a written section, so you can use a calculator to calculate that out. Okay, and after calculating this out, we have what, 64, negative 64 plus 160 plus 4. That should give us 100 feet. So the ball is 100 feet in the air after 2 seconds. Okay. The next question is, what is the maximum height the quarterback throws the football, and when will it reach that maximum height? So that is the vertex. So we need to find the x value of our vertex first. We're going to use negative b over 2a. So our b is 80, so we're going to go negative 80 divided by negative 16 times 2. Or 2 times negative 16 is really what I should have done. So we're just going to calculate 80 divided by 32 is 2.5. So there's the x value of our vertex. To find the y value of our vertex, we're just going to plug that 2.5 in for our t, or whatever variable we have. Plus 4. So I calculate that out, and we get that's 104. So we have our vertex at 2.5 comma 104, but they ask us to interpret what that means. So it means that there is a maximum height of 104 feet at 2.5 seconds. There we go. Okay, question C. It says, after how many seconds does the football take to hit the ground? This is the x-intercept. Okay, so to find the x-intercept, we're going to take our equation and we're going to set it equal to 0. So let's go ahead, and I'm going to factor a common factor out. You don't have to do that, but it might be a little bit smaller numbers to work with, which would be nice. Minus 20x minus 1 equals 0. I'm going to, let's see. I don't believe this factors, so I'm going to use the quadratic formula. We've got here x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I believe the one that you have on the test will factor. I'll double check and let you know in class, but this one isn't, so, or maybe I'm wrong and I'm just not seeing it. We're going to go negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times our a. And there's one little thing I need to fix. That's supposed to be a negative 1 on our c term. So fix that. Okay, so we calculate that out. Here we get x equals 20 plus or minus the square root of 400 plus 16 all over 8. And I don't care actually the exactness of this. I'm trying to get an estimation. So I'm going to go 20 plus the square root of 416 over 8 and 20 minus the square root of 416 over 8. So let me calculate those out. So this first one is 5.04 seconds, and the second one is negative 0.045 seconds. All right, so those are the time the ball is in the air. Now our negative one does not make sense, so our final answer is the ball is in the air 5.04 seconds before it hits the ground. That's our final answer. Our initial height is 4 seconds. That's our y-intercept, if that's being asked for. And you can find the height at any time if you just plug that value into the equation. The time in the equation. You can also find the time of any height by plugging the time or the height into the equation and solving for time. So there's lots of fun stuff you can do there. Okay, questions 15 and 16. This is going to be from section 38. And these aren't terribly difficult. The first thing wants us to rewrite the logarithm equation in exponential form. So we're not even going to worry about simplifying these. I know it tells us to, but let's not worry about that. That's not part of the test. So we're going to take our base and I'm going to hook it around. That gives me 64 to the 1/4 power. And we squeeze those together, it pushes the x out. So there is the exponent form of my logarithm. Same thing with b. I have my base, I'm going to hook it around. I get 8 to the x, and that pushes the 12 out to the other side. All right, with that we can go the other way as well. If we have exponential form, we can rewrite our exponential form in logarithm form. If you can get this skill down, it's going to be so helpful to you in college algebra. So that's why we do have a couple questions just going back and forth between exponent form and logarithm form. All right, now we can also simplify logarithms. You can simplify logarithms by writing them in exponent form, or you can use the rules of exponents. So some of the rules of exponents, and this is also from section 38, would be if you have log base b of 1, that is always 0. Log base b of b is always equal to 1. And, log base b, b to the n power is n. So these three rules, very simple. So on question 17, we can look at b and c without doing a single ounce of work. We have log base 5 of 1. Using the rule, that is 0. And that is all you need to do. Log base 6 of 6, that is 1. They reduce that way. Now on A, there is a tiny bit of work to do. I can rewrite 81 with a base of 9. I can say that is 9 squared. So then using the third rule, this simplifies to 2. Now that is pretty much it for my logarithms except for graphing, but you're going to find out graphing logarithms is not that difficult. Okay. This is question 18. This is great. It takes one whole page. That's nice because then we only have 3 more pages left. So we're going to graph f of x equals 8 to the x and g of x equals log base 8 of x. So we're going to say, okay, f of x equals 8x always will go through these certain points. They will always go through the point 0, 1, and 1, whatever the base is. The domain for exponential functions is always negative infinity to infinity, and the range is always 0 to infinity. There will be a vertical or a horizontal asymptote at y equals 0. So if we take that information and plot it on our graph, we get 0, 1, 1, 8, the horizontal asymptote, horizontal for exponent, sorry, vertical for logarithm. So there we go. There's our graph. The next thing we want to do is we want to graph log base 8 of x. Sounds scary, but it's not. Anything that's an X becomes a Y, and anything a Y becomes an X. So we can just flip that around. The 0.01 becomes the 0.1, or sorry, the 0.01 becomes the 0.10. I said it right. It just didn't sound right in my head. The 0.18 becomes the 0.81. A domain, which are the X values, become the range, which are the Y values, and vice versa. The range becomes the domain. And then we have the asymptote y equals 0 for the exponent, so the y is just replaced with an x. Okay, if we go and put that stuff on the graph, we get the point 0, 1, and 1, 0, 8, 1. We have this vertical asymptote, and there we go. So they should look the same, just kind of in a different place. They are rotated over the origin. So that is all we need to do for this problem. This problem takes section 37 and section 38. They kind of are linked together. So there we go. All right, for question 19, this is the easiest question on the test. Find the center and the radius. So the center, we just change the signs inside the parentheses. So the value on the x is a x minus 5, so that becomes a positive 5. And a plus 2 on the y becomes a negative 2 for y. The radius, we just square root the right side, so our radius is 12. There we go. So that is all we're going to need to do for the circle or for the conic sections, other than matching the equation to the name and the graph. Okay, question 20 then is going to have us match each equation to each graph. So I have this equation, this equation, this equation, and this equation. So there are my 4 equations. So the first equation is a parabola. And if we match the shape of the parabola, that's D here. So A matches to D and D. Okay, let's look at B. B is a circle. And there's our circle right here. So B is going to be A and for the name and C for the graph. For the blue one, we have, there's a minus sign in there, so that's a hyperbola. Our hyperbola is A. So for C, you're going to write that matches to C for the name, A for the graph. And then the last one here is D. D is going to be an ellipse, and B is my ellipse graph. So we're going to say that D matches to B for the name, ellipse, and B for the graph. So you're just matching which graph goes with which. That would be a multiple choice question. Make sure you understand how the multiple choice question is set up. It's a little bit weird, but I think you guys can do it. Okay, I know there's one more page in your worksheet for the test review, but I'm not going to do it because those are the bonus questions. So I'm going to let you try and figure them out on your own. We have, I will give you the answers for them on the written part, but I'm not going to talk through them. So that is it for the test review. I know it's kind of a long one. There's a lot of stuff. I did forget to tell you that question 19 and 20 did come from 39, but I think you probably figured that one out. If you have any questions, feel free to let me know, and good luck on the test. I know you'll do great.